Welcome everybody to another exciting episode of Mr. Eiler's Physics Lectures. Today we're going to actually do something pretty darn easy, so I think it's about time for a little bit of that. You guys have been working pretty hard. Today we're going to talk about relative motion. And let's start, before I actually tell you what it is, with just some examples. Here's a picture. This is either Orville or Wilbur, I'm not sure which one, in a glider. So this was one of the very first airplanes ever made. And here's something to think about. Here's kind of what relative motion is. So we imagine him flying by and going down to the bottom of this little sand dune, and that's pretty cool. But something to think about. Really, the important part for the airplane is not how fast he goes by the ground, but how fast the airplane goes through the air. So the airplane flies not because it goes across the ground at a certain speed, but because it goes through the air at a certain speed. The air goes by the wings, making lift, helping it fly. Okay, so we really need to think that there's a little more going on here. We really need to think about the motion of the airplane relative to the air, and then the air relative to the ground, or relative to us. So let's do another example. Now, how about this one? This plane is flying, sort of, but you can tell there has to be a breeze here. So the airplane thinks it's going through the air, and it really is, as a matter of fact. The air is going by the wings, providing the lift, but we also have the air going across the ground. That's why this thing is up in the air while they're holding on to it. So we've got the air and moving compared to the airplane, and we also have the air moving compared to the ground. All right, so let's have a look at this idea. Let's do a little math with airplanes. Very easy stuff. Okay, so the airplane flies through the air at a velocity of v. That's that red vector there. Let's pretend there's no wind. So the question is this: what speed does the person standing on the ground see the plane going by at? Well, since there's no wind, let's just pull our velocity vector down for the airplane. It's a little long, but that's close. It's going at a velocity of v. Okay? Now, next problem. The plane still flies through the air at a velocity of v, but now the air is moving at a half v in the same direction as the plane is going. Well, the plane doesn't care if the wind's blowing. It still has to go through the air at the same speed to fly. So that v, the red one, is really the velocity of the plane relative to the air. And the air relative to the ground is moving at a half v. Okay, so listen again. The plane compared to the air is moving at v, the red v. The air relative to the ground is moving at a half v, the blue one. So the question is, what is the speed of the plane relative to the ground? Well, let's take the red vector, plane relative to air, and let's add the air relative to the ground. So how fast is the plane going relative to the ground? Well, it's going 1 1/2 v. We add the two vectors together. So it's kind of a step process. The plane relative to the air relative to the ground. All right, let's do a crazy one. Now, check it out. The plane relative to the air still flies at a velocity of v, but now the wind is going twice v the other direction. I want you to add these two vectors. First, draw the red one down below, then add the blue one to it, and tell me what you end up with. Pause me, and when you're ready, we'll start. Alrighty, I'm going to move on. So let's pull our red vector down here. There's v. Okay, that's the plane relative to the air. Now let's pull the blue vector down, and it is twice as big going the other direction. So again, red vector, plane relative to air, blue vector, air relative to ground. So how fast is the plane moving relative to the ground? It would be moving v in that direction. I don't have to put a negative sign on it because the arrow tells me the direction. So if I'm on the ground, guess what? This plane looks like it's flying backwards to me. This is crazy. If the wind is blowing hard enough, now you'd need just a son of a gun of a wind to do this, but it could happen. How many of you have ever seen a bird floating on a thermal and looking like it's not moving? It's just gliding out there. Well, the wind has to be going by it for it to fly. Sometimes that bird will actually go backwards a little bit. All right? Think about another one. You're driving in a car, and a car pulls up next to you, your friends. Okay? You want to race, so you've got a big engine. You floor it, and you go forward compared to the other car. Okay? Ignore the ground. The car your friends are in, compared to you, moves backwards. Are they really going backwards? No. But they are relative to you. Okay? Alrighty, let's do another example. Here's the fun one. Now let's look at an airplane from the top, from above it. And it's flying along at a velocity of v. I have two v's down here for the black. Let me erase one. Sorry about that. It's flying to the right with a velocity v, but the wind is blowing down, or that would be northeast south with a velocity of v. What's the actual velocity of the airplane, okay, compared to the ground? So again, black arrow, velocity of airplane relative to air, blue arrow, velocity of the air relative to the ground. I want you to add those two vectors and show me the velocity of the plane relative to the ground. Alrighty, I'm moving on. Here's what I got. I copied the two vectors down. Now, what I'm going to do is I'm going to move the velocity of the wind compared to the velocity of the plane, or compared to the ground, at the end of the other vector. And the actual velocity of the plane is that way. Okay? And we'll make that a red velocity. Alrighty, so now you see again why we need vectors. And you can see that the plane is actually not going directly to the east. It's going to the east and the south at the same time. So we have a couple of these problems. You'll see them. They're not too hard. Here's an example. Hope you enjoy yourself, and have a wonderful day.